several miles per hour in some cases. In northern Italy, there's a series of relatively steeply inclined sedimentary strata. Okay, they should be extremely stable because they're into the ground. Where are they going to go? Well, what has happened in that area is over time, and I didn't have them steep enough anyway, so different diagram. Because these are the Alps of northern Italy. When we think of Alps, you think of Switzerland, but in Italy, there's the Dolomitic Alps. There's a series of mountain ranges in northern Italy, far northern Italy, the Austrian-Swiss border called the Dolomites. Well, in the Dolomites, there are deeply incised stream channels. Deeply incised. Something like this. So now what we have this stream channel cut down through the area. What has happened is nature has basically carved this nice channel. Nature has basically done a process called undercutting. Undercutting is removing support for rock masses or debris material. So all of this support happens to be wiped away by the stream. Now, the Dolomite Alps, like every mountainous system, will have vibrations in the form of earthquake tremors. And periodically, some of this stuff will shed off and go cascading into the nearby valleys. And it's been documented, it's been noted over a period of time that materials will shed off of this material. All of these units are weak limestone and shale, and shales are made up of clay. Clay, when it gets wet, expands and gets extremely slippery. So we have limestone units up here, limestone units, shale units, again, very, very unstable. In Europe, one of the primary problems in Europe is a lack of energy. Unlike the U.S., where we have an abundance of oil and gas and coal and so on, parts of Europe are basically fossil fuel free. Italy has no oil, no gas, no coal, so they rely on other means of energy. And so consequently, they look at this, and if you were an energy expert, what would you put here? You put a massive dam. And you create hydroelectric power. Hydroelectric power is clean, it doesn't obstruct too much of the environment, and it just seems like the thing to do when you have a landscape like this. Geologists would tell you, no, this is not a good thing. Engineers would tell you, yeah, we can do it. And so the two groups disagreed, but of course, the industrial base, the corporate base, and we need the energy, we need cheap energy, go ahead and let's build it. Build it and nothing will happen. So they put this dam in here. The dam was over 800 feet high. One of the highest dams in Europe. Very impressive. The only problem with this dam is once the water begins to build up in here, water begins to filter into these bedding planes. Water seeps up like capillary action, shooting up these bedding planes. The clay expands, and so expanding clay reduces the friction between that layer and the other layers. The clay gets slippery. So there's a possibility that we could have some materials moving over a short period of time. Then to add to that, it begins to rain. And so now you have water overloading this stuff. So you have water overloading, you have water seeping up in the bedding plants, and in the construction phase, you've created enough disturbance that you weaken the joints between these bedding planes. The engineers finally realized they had a problem when they noticed that the surface unit, the entire surface unit, was moving at 1 centimeter per month. They said, whoops, we've got to watch this. They watched it for a period of time, and lo and behold, it went from 1 centimeter per month to 1 centimeter per day, per week. Now, a centimeter isn't all that much. It's a little more than half an inch. But imagine a block several tens of feet thick, maybe a kilometer square, moving gradually down this slope into your reservoir. So they said, well, now it's moving really rapidly. We better watch it carefully. It went from 1 centimeter per month to 1 centimeter per week to several centimeters per day. So all of a sudden this thing was moving 3 and 4 inches per day. And at the very end it was moving 80 centimeters per day. 80 centimeters is several feet. You get a block like this moving, they say we've really got a problem. Now this reservoir is almost filled with water. Look at this reservoir like a big pail. And now you take this big honking rock and you throw in the pail, what's going to happen? The water's going to go cascading out. Well, in the early evening hours in, I don't know, October of 63, I think, this top sheet just sheared right off, dumped into a reservoir. A wall of water came out of the reservoir that was over 200 meters high, 245 meters high. Went cascading down the valley, and down the valley there's this nice sleepy village. They got flushed out like no toilet could have flushed them out. I mean, literally wiped out the entire village. 2,600 people in a matter of 7 minutes, slide, splash, boom, you're done. The engineers are right. They could build a dam that withstood this activity. Dam is still there. No damage to the dam at all. The reservoir is now empty because that stuff is still moving down. They've destabilized these slopes. So what we have here is a prime example of a rock slide. So this would be a rock slide.